we will be looking at absolute value inequalities, combining our understanding of absolute values and inequalities. In solving absolute value inequalities, we need to take into consideration a few things. The first is that we'll be rewriting that inequality either as an intersection or a union. So if we are working with an absolute value inequality that is less than or equal to, we're going to be looking at the intersection or that and statement. Remember the idea of less than. For example, if we have the absolute value of 2x plus 1 is less than or equal to 6. Let's think about that absolute value inequality on our number line. We know that absolute values are looking at the distance away from 0. That distance could be from 0 to 6 or 0 to negative 6. And in a less than absolute value inequality, any number that is less than or equal to 6 would make this statement true. So 1, 2, 3, 4, 5, or negative 1, negative 2, 3, 4, 5, and any number in between would make this true, which is why we have an and or an intersection. This is a little bit different than our greater than or equal to idea. If we have a greater than or equal to, such as the absolute value of 3x minus 5 is greater than 4, again, we are looking at that distance away from 0, and we want to know where that distance away from 0 is greater than 4, or because it's absolute values, it could be less than a negative 4. This is why we will create or statements or union statements. Our second step is to take these equations, and we'll be creating two equations. One where we drop the absolute value sign, and the second where we drop that absolute value sign and negate the right-hand side and reverse the direction of the inequality sign. We'll take a closer look at this second step. So here I have the absolute value of 2x plus 1 is greater than 7. So I'm looking at a greater, an or statement. In setting up my equations then, my first equation you can see that I have dropped the absolute values and kept the statement very similar. Secondly, though, I know that that greater than 7 also means less than a negative 7. Notice how I reversed the inequality sign and negated that right-hand value. From there, you will continue to solve these two equations as you would two inequalities. Solving each inequality, I have x's are greater than 3 or x's are less than negative 4. I want to now graph that solution and then write it in interval notation, coming up with the idea that my interval solution answer is negative infinity to negative 4, union 3 to positive infinity. Looking at a less than statement or an and statement, we are looking where the idea of x minus 5 is less than 3. So if x minus 5 is less than 3, we also know that x minus 5 could be greater than a negative 3. And notice this is an and statement. We have reversed the inequality and negated the right-hand value in the second equation. Again, solving as a compound inequality, I get x is less than 8 and x is greater than 2, which I could write as 2 is less than x is less than 8. Graphing that solution and writing the answer in interval notation, I find that my solution is between 2 and 8. And as always, if you want to check these, substitute something in that interval into our original equation. I'll choose 6. If I have the absolute value of 6 minus 5 is less than 3, I see that 6 minus 5 is 1, and 1 is less than 3. So that's a true statement. So always remember that you can check your answer by substituting in a value from your interval notation.